Hi guys, welcome to AEV and this is Vishnu. So in this illustration, a firm has an investment proposal requiring an outlay of 40,000. The investment proposal is expected to have 2 years economic life with no salvage value. So in the first year, in year 1, there is a point 0.4, that is 40% probability that cash inflow after tax will be 25,000 and zero point 0.6 probability on the cash inflow after tax will be 30,000. The probability assigned to cash inflow after tax for the year 2 are as follows. So here they have given a table which contains income probability. For the cash inflow of year 1 will be 25,000 and probability is 1, and then for project B it will be, or the next project it will be 30,000 and probability 1. Going ahead, cash inflow for second year it will be splitted by 12,000, 16,000 and 22,000, and the probability will be 0.2, 0.3 and 0.5. Going ahead, on the second one it is 20,000, 25,000 and 30,000. The probability will be 0.4, 0.5 and 0.1. The firm uses a 12% discount rate for the type of investment. So and then you are required to construct a decision tree for the proposal investment project. Number 2, what is the net present value will be the project yield if worst outcome is realized. What is the probability of occurrence of this NPV? Number 3, what will be the best and the probability of the occurrence? Number 4, will the project be unacceptable? 12% discounting factor as year 1 is 0.8929 and year 2 is 0.7972. Second part of the question, do the probability index and the NPV criteria on evaluation investment proposal leads to the same acceptance, rejection and ranking decisions? In what situation will they give the conflicting result? Then here we have, so this is the question, and going ahead with the solution. First we have a decision tree. So for that we have a cash outlay of 40,000. So 40,000 is the initial investment or the capital which the company should pay, right? Yes. And then for when it is compared to income, it is split into 0.4 and 0.6. So 0.4 for year 1 and 0.6 for the next probability. Okay. So it will be as discussed in the question, it will be year 1 will be 25,000 and year 2 will be 30,000. So as mentioned, 0.4 it will be 25,000 and 0.6 it will be 30,000. Then we have on the second year we have two probabilities, which is 12,000, 16,000 and 22,000 for second year, which is denoted over here, that is 0.2 as 12,000, 0.3 as 16,000 and 0.5 as 22,000, right? Then we can take the next probability, that is 20,000, 25,000 and 30,000, which have a probability 0.4, 0.5 and 0.1. So here 20,000 which is 0.4 and 25,000 which is 0.5 and 30,000 as 0.1. So while checking here, we will get 6 probable answers. So we have 6 options. One is this, 2, 3, 4, 5, and 6. Okay. Next, we can compute the probability percentage, which is for the first segment. It will be 0.0, that is 0.08, which is 8 percentage. So 8 percentage is nothing but when we multiply 0.4 with 0.2, you will get 8 percentage. In the same way, 0.4 into 0.3 we will get 12 percentage, and 0.4 into 0.5 we will get 20 percentage. The same way, when it comes to the next probability, which is 0.6, therefore 0.6 into 0.4 you will get 24 percentage, and 0.6 into 0.5 you will get 30 percentage, and 0.6 into 0.1 you will get 6 percentage, and overall it will be 1. If it is not 1, then your answer may be mistaken. Going ahead, the decision tree above shows that there are 6 probability. As I have discussed, we have 6 probability outcomes, each represented by a path. The net present value of each path are 12 percentage discounting factor. So the discounting factor, as we discussed, it will be 12 percentage. Therefore, we need to multiply the discounting factor with 6 outcomes, which is 25,000 for the first 3. That is 25,000 into the discounting factor for the year 1 is 0.8929. So we have 3 outcomes, right? So when we need to multiply 20,000 into 0.829 with all 3 outcomes, and over here we have different, on the second year we have the different outcome, which is 12,000, 16,000, and 20,000 multiplied by the P factor for the second year, that is 0.7972. And when we take the sum, it will be 22,328 plus 9,566. It will give you 31,889. In the same way, when we check the point 4th, 5th, and 6th row, there will we have 30,000 each for the probability of 0.6. Therefore, we have 3 solutions for that also. Therefore, we will get that 30,000 multiplied by 0.8929, which is the P factor for the first year. And over here on the second year, we have 3 different probabilities and 3 different answers, which is 20,000, 25,000, and 30,000 multiplied by 0.7972, which is the P factor for the second year. When we take the total, we will get 42,731 and 46,717 and 50,708. After computing such amount, we need to deduct the cash outlay from the total income. That is 31,889 is the total income or the discounted income multiplied by the cash outflow, which is 40,000 in the beginning. So when we deduct, we will get a loss of 8,111. The same way, we have 35,078 in the second option, minus 40,000 will get negative 4,922. The same way we will get for the third option, it is negative 139, and then 2731, which is the positive, and 6,770, 10,703. After computing such amounts, which is the net present value, we need to multiply it with the probability factor or the probability which we have computed over here, that is joint probability, that is year 1 probability into year 2 probability, which I have shown a table like serial number This is the option which is 1 to 6 probabilities we have, and NPV which we have taken from the above table. Then we have joint probability as we computed from the decision tree area 0.8.12. So when we multiply the net present value with the joint probability, we will get the net present value after considering joint probability. So the total amount will is positive, that is 2045.6. So as we conclude, according to NPV method, project A would be preferred, whereas according to probability index method, project B would be preferred. Net present value given gives ranking on the basis of absolute values of rupees, whereas probability index gives ranking on the basis of ratios. Although PI probability index method is based on the NPV, that is net present value, it is better evaluation technique than NPV in the situation of capital rationing. So guys, thanks for watching this video. I hope you are clear with this example. If you find this video helpful, please subscribe.